I am Sonam Gupta. I am one of the community managers at AI Camp, and I also work as a developer advocate at a company called Telnix. So if in case you guys are interested in building voice agents, please come talk to me. All right. So now I know there are many people who have been to AI Camp events here. Welcome back. And to all the new faces, welcome to your first AI Camp event, and I hope it's never the last. So who and what is AI Camp? We are basically a global AI developer community. We are spread across the globe. You can see all the red pins. More are getting added as we speak. And we have many local community chapters in different continents. We have many different ways in which you can get involved with our community. We have, around 50,000 plus AI developers. I think in SF, we have hosted over 130 plus events already, which is pretty cool. And thanks to all of your support to make this happen. So if you wish to get involved, please, if you want to give a talk, please submit your topics to this particular email that you see on the screen, info@aicamp.ai. If you wish to sponsor more meetups and events, if you have venues, or you just want to sponsor food and beverages or anything you like, we are all ears. Now, as I said, we do lots of different events. We are not only limited to in-person, but we also have online events like you see on the screen. We have many upcoming ones virtually, and then we have the next one on the 15th of December and 16th of December. The 16th of December, and both of those are again with Google, so please check them out. All the event information, you can find it on aicamp.ai, that's our website. And you can filter down from based on which city you are in, and you have online and in-person events listed out there. Now, I want to do a quick community shout out. Given the time, I'm going to have only 2 people maybe shout out if you guys are hiring or looking for a job or looking for a co-founder, for example, because let's face it, it is SF. Every other person is building a startup. So 2 people, raise your hands, and any 2 people who wants to do a quick shout out, I will give the mic to you. No? Oh. Alyssa, 1 second. Okay.
All right. Hi, my name's Kurt Chan, co-founder of AIBI. New AI startup, and we're looking for partners. People, if you are, so we're an AI product for business intelligence. So if you're a data analyst, we'd love to partner with you, have you test it out. And I suppose if you're an angel investor or VC, I wouldn't complain either. So that would help too.
Thank you.
Hey, my name's Terry Damiba. I'm a developer advocate at Quadrant, and I actually want to shout out a hackathon that we're doing right now with Google. Shout out Google, Google DeepMind and Free Pick. If you're interested, just go on Luma and search up Google DeepMind. Quadrant's a vector database, so we're showing you how to combine search with what you'll learn about tonight. So if you're interested in building something, go on Luma, search for Google DeepMind, you'll see the hackathon. Thank you.
Thank you so much. All right, so now if you hadn't got a chance to give a shout out right now, if you scan the QR code, it will take you to our Discord community, and you can share whatever you like there. We have San Francisco specific channel, so anything you want to share, you want to give a talk, feel free to reach out to us there on Discord. Huge thanks to GitHub, as usual, for their lovely, lovely office, and Google Cloud and Snowflake for sponsoring this event. On to our talks. The first talk is by Sanjay Mishra from Google. Let's hear it for Sanjay. Oh, while he connects to the laptop, one quick reminder, I don't know if everybody got a chance to look into the QR code, but that QR code basically takes you to a Google form, which you just have to fill it out. It takes like a minute. This is an AI Camp community feedback that we would love to get from you guys. And I will run a raffle towards the end of the event, so please don't leave. If you want to earn $25 Amazon gift cards, not Amazon credits, Amazon gift card. 2 lucky winners. All right. Quickly scan the code so I can give the mic to Sanjay. 3, 2, 1, go.
This one works, right? This. Left is right, right is left. So, all good. Good evening, everybody. All righty. Thank you. Thank you for coming in here. This mic, I have to stand here? That works, or? All righty. All righty. I'll hold it. Okay, and I'll put it down when it need to be done. I have a quiz before we get started.
Hi, sorry, real quick. Please use the handheld microphone instead of the podium one if you pick it up.
I see.
Thank you.
This one? This will work? Yes. Okay. How many of you have been working with agents? How about the rest of you? Travel agents, life insurance agents, real estate agents? So the time will come when all these agents, secret agents, yes. All right. Who knows, right? The time will come when all the agents will work together. Some of them will be humans, and some of them will be non-humans. And when that time comes, we will see that AI would have very nicely assimilated in our life, because that's what is happening right now. And as our world around us is being transformed by AI, the key to true transformation comes through data. So this is a heavy sentence. What I try to put together is very simple. No data, no AI. As simple as that, right? Because what is liquid water to life on Earth? Data is to AI. If there was no liquid water on Earth, there won't be any AI. Good. Okay. Some people are called body and soul and what. Please use your whatever metaphor works for you, and I'm with you. The key thing, though, is that AI is the equalizer. Everybody has access to AI. You and your competitor have access to the same models, same language, same topologies, same architectures that you and your computer have access to. But you have access to your data, your business data, that your competitor does not have access to. So you can actually create true differentiation for your customers, for your business, by truly harnessing your data. Okay? But data comes in many forms. Data comes in the form of, let's walk around a bit, structured data, we all are very familiar with. Data comes in the form of unstructured data, that also very we're familiar with. Then data also comes multimodal data. Because when you go to a doctor, they are trying to combine X-ray report, murmur of the chest, and also the temperature and anything else they can find out, combine all these together so that they can actually use that to diagnose the right disease, prescribe the right prescription for you. So all these multimodal data need to be combined together. They cannot be separately being independent of each other. Now, they all reside today in different places for good reason. Because sometimes they reside close to the origin, sometimes they reside where it is more efficient from cost-wise, sometimes they reside in a place where it is easy access pattern and so on, right? So when you're building an application like what I just gave an example of, a doctor trying to do diagnosis of some symptom through your vitals, through your X-ray report, through your audio of the chest murmur and all these things, they need to go through all these things. They need to find data in databases. They need to find the vector data in a vector store. They need to find object storage where the images and videos and other things are stored and try to make sense out of it. Another approach would be that if your database could do it all. If your database doesn't do it all, what will happen is that you'll have to move data around. And when you move data around, what do we call it? It's the one of the challenges, but what do we call it? The process of moving data from one place to another for some subsequent processing? ETL, right? Somebody said ETL. What does ETL stand for? No. It is error-prone, tedious, and introduces latency, right? So the moment you're moving data, you are actually telling the subsequent system that I don't care for you. I'll give it when it arrives, right? Wait for it. So there is dependency being created, right? And obviously, if it is error-prone, it can be even more detrimental to your subsequent things. So what is happening is that now I started with that. There are human agents, non-human agents, they all working together and so on. What this process has done actually is that expose things, expose in a good way, providing exposure to things that did not have before, which means that if you have good data, good intelligence, it will be known, be used, amplified way very soon. If you have bad data, which has resulted in bad intelligence, it will also be used by a lot of people very soon, very effectively. So to make sure that you are able to make good use of data, make sure that you are using the good data. What is good data? The most important data about your business is the data that is representing your business. Your customers, your orders, your transactions, your partners, your inventory, your flow of information. That's actually data. That's actually very, very central to your business. And you want to make sure that wherever you're doing those kind of processing, taking orders, maintaining the list of customers, your dispatches, your sales orders, your anything, wherever you're doing that, you do AI right there. So bring AI to data instead of taking data to AI. And it's this interplay between data and AI is just not one way. Is that, okay, it is the AI which needs data to do all the stuff, but what is happening is that data and AI use each other in many different ways. You use data to train AI, we talked about, and many of that is used for predictive AI. You train, you create models, and then you can predict based on that model. You can use already trained and model and then put it on data to do inference. But what is also happening is that data infrastructure can also be managed by AI. So you can actually you can create a database, hosting clusters and so on by simple commands through the AI. You can actually create the schema, your database design. You can even actually load test data through AI into the database. You can actually also troubleshoot. You can actually do any performance tuning through AI. So data is helping AI, AI is helping data. So this interplay continues together. What this means is that the databases must evolve. They cannot. You have a question?
I just want to say the very sample is AlphaGo. AlphaGo with the data and AI is the step-by-step scroll up.
Okay, good. Thank you. So databases must evolve. They cannot stay the static storage of information anymore. They need to be able to do AI in a way so that all those modalities that we talked about, all the use cases that we talked about can be enabled in a very efficient way. So what we're doing, so by the way, if you have like familiar with TV shows, not too long back, we used to have a TV show called Everybody Loves Raymond. Yeah, right. And now, when you talk to databases, people actually, they love Postgres. It's a new situation where everybody loves Postgres. It's a good thing. Everybody loves Postgres. It's a good thing. So as a result, what is happening, all those data companies who are not necessarily a Postgres type of data companies now also desire to have a Postgres offering next to each other because it is powerful. It is powerful, it is extensible, and it has got. So what we have done, I have not introduced myself yet. You just probably saw my name. My name is Sanjay Mishra, and I love Postgres SQL, okay? And then what I also do is that I lead the product management team for a product called AlloyDB, which is Postgres and Postgres++, which is open source Postgres, plus some spices, some sauce, some salt, some, you saw pizza serving there. So all these put together to make the database serve many workload, including AI workload better. You all know this data is everywhere, everybody wanted to see. So what we have done in AlloyDB is that to ensure that you could build the type of AI applications that you want. It could be a chatbot where you are interacting with a customer, or a customer interacting with your system. It could be a system that does a process automation for you. Or it could be a natural language processing. It could be a product search. To do these kind of thing, you need a few things inside your database. Thing number one, you need an awesome AI-powered search through vector processing, which AlloyDB provides. AlloyDB, being a Postgres database, inherits PG vector extension from open source Postgres and all its goodies, plus adds a few more Google-specific modeling, for example, a scan index to make those things better and faster. So that's one thing that is absolutely needed for a database to be able to an AI native database or AI ready database. What we have also introduced is called AI functions, where you can actually use, just like you use SQL functions or any other kind of Python functions, any other kind of Java functions that you use, these functions are AI functions. They can actually take a quote unquote a prompt, process it for you, being part of the same language that you are interacting with the data, and I'll show some demos about that. And then a natural language interface. Natural language interface is super, super important because computers think in what language? Binary, 0, 1, binary 0, 0, 0, 1, right? Yeah, and then humans have made that interaction a little bit better by finding out higher level languages, C, C Sharp, Python, Pascal, Java, whatever is your favorite one, right? But guess what? In human thinking, totally different thing. Human think about human languages. I'm sure all the languages that you all speak, know, hear, and learn were built hundreds and hundreds of years back. When it comes to language, old is gold. Because through the years and millennia and centuries of evolution, the languages have a certain kind of semantics built into that the computer language is not easily representable, right? So how you do that? That's why it's super important for the natural language interface system to be able to truly understand the intent of the user, because user is more conversant in a natural language, computer does a non-natural language, and hence that translation has to happen with the actual intent and context in mind. And if we have time, I'll show you a demo for that too. And obviously, to do all these things, you need to integrate with all the orchestrating frameworks. Some of them are first party within Google, some of them are third party. Same as the models, Google's own models, as well as the models that are built by other partners and other model providers. They can all be accessed seamlessly from the AlloyDB interface. And we'll show some of them. Best to see some demo before anything, it becomes too dry. So I have a recorded demo, but I took a risk that, okay, I'll show a real demo. Let's see. If the demo breaks, then I'll go to the recorded demo. But all of you wish me good luck, pray to the demo god. All righty? Left is right. I have to remember the left is right. Left is right. Where is my cursor? Left is right. Okay, here. Right. Yeah, okay. Oh, right is left. So when left is right, right has to be left. Okay. We'll go there. First of all, I knew there will be pizza today here. So I built all my demo on pizza. So what I'm showing you is something on AlloyDB Studio, which is a UI interface to interact with the data that is in AlloyDB. And you can write your SQL statements here. You'll get a result. It's a very simple thing like any other database interaction tool that you know. So what I want to show today is that, okay, I have a few tables, some data over there, and it's all about pizza and pizza review. How good is the pizza, okay? So let's see what we can find here. So I'm trying to find out review of the pizza from anybody who lives in a country that starts with I, okay? So we got it. It's running. You can see Italy, Iceland, India, Indonesia, and so on. So all over the places coming in, okay? I said, let me be a little bit Think a little bit and force you to think. So the first SQL set that is a pure SQL statement, it has got where predicates, it has got a like clause, it has got whatever you are trying to find it and so thing. If you look at all the columns, I selected all the columns, there is no mention of a continent there. You can see all the columns are displayed over. There is no mention of a continent here. So the database has no knowledge about the continent. But guess what? AI has the knowledge about continent. LLMs have been trained on the corpus of data about all the continents. So LLM, behind the scene, which is connected to this database, knows which country in which continent. And what I'm asking it here, through AI function called AI.if, I'm asking, all right, give me the reviews, pizza reviews, but only if it's from a European country. Apparently, European countries starting with I know how to make pizza. Countries like other countries who start with I in other continents may not know how to make good pizza. So let's make sure that we get the pizza review from the right people. Alrighty? So this will do and find out. Note that there is no information about the continent in the database. It's going to use external knowledge through the AI.if statement, call the LLM, find out, and bring it over. See, I get only Italy, France, and so on. If you can look at, I have taken out the I filter, so it'll show me all the things. So did that work? I'm going to be a little bit more adventurous. Okay. Right? I'm getting greedier, okay? Let's test it even further, right? Again, there is no information about one part of Europe is called Scandinavia. There is no information about that in the database. So let's see if it can find out using the world knowledge to find out, do I get pizza reviews from people who live in Scandinavian countries? I'll come to the question. Let's make sure the content is done, right? So you see, it figured out that, okay, the countries like Sweden, Denmark, Finland, Norway are part of a region called Scandinavia, and merge that with the information that in the database and give you the result, okay? So what we have is that not only you can use that AI.if function, part of a where clause, we just saw that, you can use things like that in a join statement, combine them with multiple columns multiple predicates that are to be joined. Here what I'm doing is that, okay, I'm joining my pizza review table with a list of restaurants table and trying to find out if, so this is a join of two tables, first of all, if the pizza was good. Was pizza good today, by the way? It's good? Okay, good. So if the review feedback is good, if the sentiment is positive, and I'm also putting in a trick question. From a city with population more than 100,000. Again, there is no mention of city population in my database tables. Database does not know, LLM knows, is going to combine both the information in one SQL statement to give the result. And obviously, I'm stretching this a lot. Not only I'm doing that, I'm using that. I'm using that in two parts of I'm using that in the where clause, and I'm putting a group by and a having. So let's stretch it to the for. Okay. This will take a moment to come back. In the between, I want to show you something latest and greatest, right? Gemini 3 just came out, right? Gemini 3 came out, and guess what? LLDB is integrated with Gemini 3. We will ask Gemini 3, tell us a few good things, more interesting things about LLDB. Let's see what it says. Okay? What it says is that this can use and I'll show you, here I'm showing the Gemini 3 preview model, and I'm going to show you how it knows what is that preview model is. It is going to use Gemini 3 to ask a question from within your LLDB SQL interface and get you information. And obviously, it's looking at the product documentation and so on, and then figuring out what are the three interesting and good thing and bring it up to you. How am I able to access this? This is very, very simple. The thing is that the LLDB service model, what we call is a model endpoint management. Any AI model and that endpoint, I have access to that endpoint, can be easily integrated from LLDB through this one stored procedure. And now after the stored procedure is done, and then see model ID Gemini 3 preview model, so it is going to access that model through this endpoint, use my access point as a way to get the API key access, and get me make me use and get there. So latest and greatest models are all part of that. Oh, sorry, back. Thank you. Okay, so that's about demos today. Let's see, our demo should have come back. I love a clip-on mic. That way I can move around without having to worry about it. It's still running. It didn't eat pizza today, so it's hungry, so let it do. Okay? Alrighty. Okay, thank you all your prayers worked. Demo did not crash. It went through. The one query taking a little bit longer, and that's okay. And I pushed the query to it actually by putting in everything that I could. Okay. So building AI application is very interesting, a lot of fun, and you saw you can play with that. It's pretty geeky stuff, but sometimes it takes a toll on the user to manage and maintain the system. And I talked about there is generative AI, there is predictive AI, there is agentic AI. And while coming over here, while just I was pulling onto this all, I saw physical AI. I saw a neuro car, autonomous car driving, no driver. It's a physical AI. So it's all doing this stuff. And by the way, Neuro uses LLDB to store tons and tons of vector data there and use that for processing. And they're pushing the envelope. They're pushing like as much as 1 billion vectors in a database. So when you have a large set of vector database, you have to create index and so on. Knowing all the parameters to be able to tune your vector index can be hard on the user. Moreover, when at the development time, you are trying to find out, okay, how to create the best possible shape and size of the index, because vector indexes need a few parameters for you to define them well. So what happens is that you need to build those expertise to be able to really create, define, and maintain efficient vector indexes. What we have done is that we have given you two knobs. One knob is call it auto index, which means is that by specifying mode equal to auto, the vector index will be created based on your data distribution, based on your characteristics of the data. You do not have to define number of leaves or my centroids, where all this stuff. People who deal with vector database every day, they will have to worry about all the stuff. The second thing what happens is that when you are actually building your application, you may not know about the actual production data distribution and so on. So for you to define all those attributes of your vector index at the development time kind of puts you in a situation that your things need to change when you go to production. But putting them in the auto mode doesn't do that. And the second thing is that auto maintenance equal to also on, which means you create the index now, but as your data characteristic changes, data distribution changes, the index will maintain itself to be a very healthy index. What I've also done is that provide you a very simple call through which you can actually do an auto embedding generation. So if you have a column on which you want to always maintain embeddings so that you could compare them with something else and so on, through this you'll be able to actually maintain, generate the embeddings for that particular column in that table, as you can see in the syntax, and automatically generate and keep it for you. It'll also do it in a batch mode for you to be able to make it efficient. And I showed you one type of AI function called AI.if. Other types of AI function exist. For example, you want to generate some data, you can do AI.generate. If you want to do forecasting, you can use another function called AI.forecast. Everybody loves to know the future, right? What will happen tomorrow? If I know what will the stock market be tomorrow, I'll plan my action for tomorrow. So same thing, whether it is weather, whether it is sales, whether it is inventory, whether it is ice cream sales when it's a hot day, everybody wants to know how many I'm going to sell tomorrow, how will my future look like. So you have your past history, you want to feed it to this model called AI.forecast, and it can actually generate for you what the future looks like for this series of the data. These are all built in within AlloyDB under an umbrella called AI.functions. By the way, all the demo I showed you were all generated by a tool called Gemini CLI. So I prompted Gemini CLI, please create me a database with the schema where I'm going to store user reviews, blah, blah, blah. Please load some data from some European country, some Scandinavian country, some Asian country, and so on. And it loaded all the data for me, created all the data for me. And obviously, the queries, I wrote the queries to be able to kind of take advantage of that. So you can all do that very powerful way. OK. In the interest of time and leaving some time for Q&A, you can do all these things free. AlloyDB is available as a free trial. You can sign up using that, and as a result, you can play with all the things and many more that I didn't have a chance to time to talk today. Very happy to answer any question. Stay around here for longer if any topics come up, and use it. And it's a very powerful instance you get. Moreover, AlloyDB is also available in a downloadable option. What I demoed you here is a cloud service version available in Google Cloud. But you can download AlloyDB and install on your laptop, in a container, in your own data center, in any other cloud, and use it to your heart's content. And then we have to do some kind of a thank you for joining us, and any feedback or anything that you have a perception survey. Aziza is there, so she can help you out on taking your feedback as well. Thank you all. And we have a few minutes to take a couple of questions, actually. You had something to say. Yes, please.
Yeah. So first of all, great demo.
Thank you.
And also cool product. My question was, when you add the country with the AI query,
Yes.
is that getting persisted so that you can use it in the future, or is it a throwaway column that it's adding?
Okay. You're using mic, so everybody heard the question. So thank you. That's not persisted. It's in your query.
So it's in your literally query. Just for that
yeah. So your queries are not persistent. You could save the query in your in the AlloyDB Studio provides you to save your queries, but it's stored under your tenant on your interface and so on. But AlloyDB itself doesn't know about what query you gave.
So perfect for agents
it's
who might
perfect for agents. It is dynamic because you asked about the. I asked about the Scandinavian country. Next question probably could have been, oh, show me some Asian countries and how do they love pizza and so on. So it's
very cool. Thank you.
Thank you. There are more on this side too.
Hi, thanks for the presentation. My question is, how does query speed scale with data? Because do you guys have some sort of like indexing for the AI on the column? Does it operate, 1,000 million or 1 billion rows? How does it go through each single row and then have like the AI generate some output? I guess, yeah, under the hood, how does all this work?
Yeah, so thank you for asking the question. It allows me to say something that I didn't have a chance to put in my presentation. So thing is this. There is a way that inside the engine, some optimizations done, and there are tools for you to scale your actually infrastructure and your hardware resources and so on. And I'll talk about both. What AlloyDB comes with is, as I mentioned, AlloyDB is Postgres ++. So one of the ++ things has been added to AlloyDB, something called columnar engine. What it does is that when it finds out that okay, this data can be put in a columnar format, and hence a vectorized processing of the columnar data is going to faster, guess what? All the vectors and everything that we do can benefit from a columnar engine representation. So within the engine, there is a columnar representation of your data that can make the fast and so on. Second thing what it does is something called adaptive filtering. The true value of all this search comes from not just doing vector-to-vector comparison and find out which is my cosine difference and less and so on, but also to add the other real-world predicates to it. For example, I want to find out in my city, the best restaurant in my city. So my city is known. So it is one of the columns, and I can filter on it. Or I want to find out, only 5 miles away from where I live. Right? So you can add all other kind of filtering in the same statement along with your all the AI aspects to it. So what the LLM engine does is that it knows based on the statistics on your distribution of data and so on, that when do I need to do in-filtering, when I do pre-filtering, when I need to do post-filtering. What does it, and we call this adaptive filtering. The query can adapt its filtering mode based on your query, your access pattern, and your data statistics. And it can apply the other filters before applying your vector search things, or it can do it at the same time, or it can do it afterwards, depending on what will help you to give you the best query performance. So that is all the things that are happening inside the engine. For large-scale operations that you talk about, millions and millions of vector processing, what obviously LLM is a single instance writer. That means you can write, you can scale it up, your write node from 1 vCPU to 128 vCPU today. Tomorrow it will be the bigger machines come up, you will have more scale up. But it also comes with readable nodes called read pools. And you can have 20 of them. And each one can scale up as much as you want. So you can imagine, for example, I talked about the neuro car, right? So it needs to access the vectors in a much more scalable way through multiple concurrent access patterns and so on. And what you can do in these situations is actually spin up read pool nodes and direct your queries to the read pool, and it'll give you the same LLM engine inside it, except that you don't have to copy the data, because LLM is designed based on a decoupling of compute and storage. So the same storage is accessed by all compute nodes, whether it is your reader-writer or the standalone reading nodes on that stuff. So that's why you scale your infrastructure, and what is happening in the engine I just mentioned before. So thank you for that question. Yes, please.
For time's sake, this is the last question, but everyone can stay after the meeting to ask Sanjay.
I'll be quick. Do people typically use this, the AI functions to generate a SQL that they'll then run in ETL, or are they running these AI functions in production?
Good question, thank you. So there are two modes to access. Even though there is natural language inside the AI query, the AI function that I showed you, it is not using it to translate anything. It is using your natural language prompt as part of your query processing to give you the right combination of data. LLM also comes with something called a natural language to results, actually called natural language for applications. Because obviously it can do natural language SQL, because you give natural language, it can give you a SQL and you can run the SQL. But not every user is a SQL user. The user may all want it. All I want is my response. All I want is my data. I have given you a natural language query. When is my flight? And it can go look at my ID, go log into the system, find out where it is, and can exactly give me my flight time and so on. Right? So to do that, you can integrate that within your applications, because now you don't have to translate it into SQL and so on. So I didn't have a time to demo that, so you can actually ask natural language questions and do that. And that's a independently usable feature orthogonal to the AI query engine itself. Thank you all.
Thank you, everyone. Thank you, Sanjay. All right, our next talk is from Daniel from Snowflake. Let's hear it for Daniel.
All right. Good evening, everyone. Yeah, hopefully this one will be kind of like very relevant to the previous one, and then welcome any kind of like interruptions during the talk. Like just feel free to let me know if you have any questions. So I'm from Snowflake. I'm a research engineer from the AI/ML org. I have been working mostly in evaluation and agent optimizations for the past year, which sounds like forever in the agentic world. But yeah, so this is fairly new. We are proposing a framework for evaluating your AI agent reliability. So I guess before we start, let's just do a quick kind of like time travel back to 2023, where the world is just swept by ChatGPT for less than a year. So how many of you guys heard about Truera? I'm not even gonna like name it what that entity is. Oh, okay. There is actually one and two. Okay. Never mind then. Well, it's my previous startup that got acquired by Snowflake a little bit over a year ago. So 2 years ago, we did this very, very miniature scientific experiment asking, I believe it was Claude 2, who are the founders of Truera? And it gave us 3 names. The only correct name is the first one, Anupam Datta. It got the number of co-founders correctly though. There are 3 founders. One of them is kind of like a close friend to our founders, et cetera, et cetera. So this was definitely not a surprise, right? At the time, LLM, without like, auxiliary memory, tool usage, very powerful retrieval engines, it's probably not able to answer the question because Truera is a relatively small company. I would say decently successful, but if we ask the same LLM who are the co-founders of Google, I'm pretty sure at the time it will get all of them correctly. So this kind of like prompt us to think through like what would be reasonable if we want to evaluate the ever-growing composite AI workflows. And at the time, it was mostly, I would say, RAG-based like architecture, right? Which I will go into details a little bit more. We all know it's been kind of like old news for 2 years now. There are more sophisticated versions of RAG architecture that are still constantly being deployed to production nowadays. But yeah, so let me just fast travel to 2025. Now, what has changed, right? You guys can see probably on the top of it, this is Claude 4, Sonnet 4. It does some sort of very cryptic retrieval. It retrieved 10 results from whoever knows data sources. I'm pretty sure there's a tab you can reveal all the data sources it tried to retrieve from. And then this time, it actually got all the names correctly and their like basic backgrounds and all that, right? So this is not too surprising, right? Because I would say composite AI workflow or systems, chatbot, LLM in general, they have gotten like fairly agentic, or they have gotten the power to be able to, that the LLM does things that it does the best, which is summarization, reasoning, generation, textual embedding generation, and that the other systems take care of like things like retrieval, memorizations, and obviously tool callings, right? So let me just make sure I'm on the right slides here. All right, yeah. So how many of you guys have kind of like look at the generalizability and memorizations of LLM? Like, what I meant by that is that look at the intersection between these two, right? LLM, like in a way, there is a pressure to make it perform better in terms of like generating the best next token, right? So when we are training LLMs, we don't necessarily tell you to, hey, you need to memorize these type of facts like super well, and then you have to be able to kind of like recollect or recall those specific facts super well. It doesn't know that. In pre-training, post-training, or RHF, and all the later like policies when training LLM, what we are doing effectively is just telling it to predict the next batch of data better. That's all it's doing, right? Token sequences prediction is all that is. So the line is kind of murky because that's the reason why if we ask the LLM, who are the founders of Google, it will most likely get it right, even dating back to 2021, era of GPT-2, GPT-3. This is because obviously there's huge pressure from the data during the pre-training stage that prompt it to be able to, well, encourage it to be able to complete a token saying, oh, this is, Sergey, Larry, all that stuff, right? So, and the line is very murky here because we often rely on composite AI system. I keep not using the word agents because there's more to that. Composite AI system, typically we needed to be able to memorize things super well, right? Retrieving data, be able to generate data insights, perform analysis on the data that you just retrieved. They all require some sort of memorization. So this is kind of like the seed for VectorDB, the RAG architecture, which I think most of you guys are pretty familiar with at the moment. This is all to be able to augment the LLM and then that it does its job. There's a task that it does the best, which is reasoning or completing the next token. So, about 2 years ago, we proposed this RAG triad. We think it is important to compartmentalize and then to decompose the sort of like at the time QA task into 3 major components: query, response, and the context, right? So if we think about an agent, a system that has to retrieve from your knowledge base, from your source of knowledge, from your source of data, then generally it will perform query decomposition, understanding the query, retrieve the context using some sort of retrieval system, whether that being similarity search, semantic search, hybrid search. This is just, in general, this is just, you have to retrieve some piece of context and then make sure the LLM has access to that. The best analogy I like the most is from Andrea Caparsi, is that LLM has a vague recollection of knowledge of the world, right? The world knowledge. However, it doesn't necessarily know how to distinguish what are their working memories. Like, for example, if you want to retrieve a specific, very, very specific, obscure fact, and then you want it to be able to generate very detailed, very accurate, very grounded analysis based on those specific facts. Right. So that's why we think this is how we kind of like describe the context pieces. This is just, it could be the retrieve documents, it could be retrieve rows from your DB, like structured data. And then finally, the response pieces is just a final generated tokens. So there are a few metrics that we thought at the time were fairly important for a RAG-based systems. Is your retrieve context relevant to the query? Obviously, are your responses supported by the context? This is oftentimes being heavily researched in the realm of information retrieval, right? There is document verification task, there is document grounding task, there is fact-checking aspect to that. That's what we meant by groundedness. And then finally, your answer has to be relevant to the query. And all of these are sort of orthogonal to each other in a sense that you can have very relevant answer, but they are just plain incorrect. Right, that makes sense, right? You can have some, I'm pretty sure like in the past 3 years, we all have been lied by AI. So that's kind of like where we're going with. Now, let me pause a little bit from RAG to agent. How many of you guys have kind of like think about how to continuously monitor and evaluate your agent once deployed in production? I guess like that's something like on the mind of you guys. Yeah, I saw some hands. Yeah, eval. We like view like evaluation as a critical piece to optimize agent continuously. So going back to this Cloud for Sonnet interface, the first piece, the previous RAG evaluation framework is still relevant because even in an agentic workflow, given it the access to different kind of tools, let's say in this case, it might have access to the internet or to some other data sources, we still need to be able to verify if all the retrieved answers are grounded, and then if your response is actually grounded by all those pieces of information. And then your final answer still has to be relevant to the query, right? Because you can have something that is fully grounded, but if your LM during the very last step in the agentic workflow, it somehow twisted or somehow forgets about the original query of the user, or it's sort of like misconstrue the original query intention, then your final answer will not be relevant, right? And then that will be sort of catastrophic in production use cases because your agent can be very long running. They can take, it can take anywhere from minutes to several hours, several days to complete a task, super complicated task, and then it came back with a final sequences of token that is not even relevant to the original question. And context relevance is just, retrieval relevance or retrieval performance. This is still a fairly critical submodule, in our opinion, in the entire agentic world. So when we enter the agentic kind of like agentic world, we have several components to that, right? Planning is where the agent tries to reason before it actually carry out any actions. It divides a plan. It breaks down your query or your questions or your task into several actionable items. Oftentimes in Cursor or some sort of tools, you will see as a being manifested as a to-do list. Now, tool use is some of the biggest kind of like investment have been like kind of like went into for the past year or two. Including the previous web search. So RAG effectively can be viewed as a single tool or a sub-tool of a agentic workflow. Reflection is where the agent tries to reason on its previous execution traces and then try to come up with feedback signals, try to grade itself, try to rate the previous effort, exploration, try to correct its course of actions, and then come up with maybe a revised plan if things go well. Memory is the very long context of tokens it had to remember, right? So at its core, a memory is still the message histories of your agentic system, whether that be in a single agent or multiple agent. And finally, in the multiple agent collaboration cases, you will have maybe division of labor, right? You will have different LLM to take on different tasks, and then they will try to converse with each other. At the moment, they are still trying to converse with each other using natural language token. Some folks can argue that might not be the most optimal cases because models can be more efficiently understand each other if they don't try to mimic human behavior. But I digress a little bit. So going back to the pragmatic world, data agents, the way we define data agent is kind of like an autonomous or almost semi-autonomous system that it will connect to different data sources, understand your query, sometimes it will be SQL queries, and then try to express, the user might express that in natural language, or sometimes it will still be in machine code or higher level code. And then it will try to plan, perform actions, such as data retrieval. It could write a SQL for you, execute a SQL in your DB engine if you have the proper RBAC set up for that, and then finally perform analysis, insight extractions, chart generation, or visualizations. So taking the data agents as a kind of like a case study, we have obviously the deep research mode from ChatGPT from a while ago, I believe a year ago. And then we have a Snowflake. We also have something similar. It's called Snowflake Intelligence. What it does compared to other commercial offering is that it actually connects to your enterprise data, try to come up with a optimized view of the semantic of your enterprise databases or your schemas or your different layers of your DB. For example, it can be the descriptions of your columns, some metadata around how your indices were created, and Snowflake Intelligence built on top of those give you a agentic view of those things, so that allows you effectively to talk to your data. Which I will have a demo in a few minutes. So let's see. This will be a demo later. So how do agent works, right? So I sort of kind of talking all over the place about memory, reflections, and all that. But back to the topic. The reason we coined this term, what's your agent's GPA, is actually we observe a nice decomposition of agentic workflow of three core components, which is goal and plan and actions or act. the empirical results, which I will show shortly, tells us a story that if your agents are aligned on goal plus plan plus act, then oftentimes, and actually over 95% aligned with human judgments, it will be able to perform really, really well in all the different dimensions, including like groundedness, answer relevance, tool usage efficiencies, and any like more granular metrics. So we devised this GPA framework with a few smaller dimensions. They are orthogonal with each other, meaning they were able to capture distinct failure modes in an agent execution. Agent GPA, it's something that allows us to look at the execution traces and then try to assess, let's say, things that should fall under the reasoning front of the agent. So let's say if your agent is devising a plan, did it actually follow through? And then did it actually perform that efficiently? So that would be the intersection of 2 and 3. That means your agent is logically consistent with all the plan that it devises previously, and it actually had a reasonably efficient iteration loop, right? So there are times in the agentic world where an agent will go on like a random walk of explorations because of some weird issue. Like often in production, we will see if a step, let's say if there's an API failures, the agent oftentimes will try to do relatively suboptimal attempts and trying to resolve that, while maybe the more optimal solution is to give back the control to the users to correct that. So that also prompts the final components in the bottom about like all the metrics that should fall under the act component. So let's say, is your agent calling the tool using the right set of inputs and output? That's what we define tool calling, the number 5 in the intersection between plan and act. So there's quite a lot here, but the takeaway here is that if we evaluate it on a deep research type of benchmark, not sure if you guys heard about the Trail Gaia benchmark, but this is a human annotated benchmark, consists about roughly about 500 traces. Each one of it is around 100,000 tokens to 200,000 tokens, so fairly long reasoning traces. And if we just evaluate every errors, all of them, or I should say 95% of them, can actually be cast under the umbrella of intersection between GNP or intersection between GNA or AMP. So that's the reason we came up with, I should say, 8 judges or 8 metrics on the screen, actually 9. The reason for that is we basically benchmark our highly decomposed, fine, granular LLM judges, and then benchmark it against a single judge that is also prompt to evaluate the execution traces and see which type of decomposition or which type of paradigm capture all the originally annotated errors in the benchmark. And this framework allows us to capture all of the high impact error. So high impact error in the agentic traces, you can imagine things like resource exhaustion. Go ahead, sorry. Yeah.
Thanks. I've been thinking on the previous slide that points 4A and 4B, plan quality, tool selection. What are, in your opinion, the factors that change that? For example, like kind of LLM, system prompt, or description of the tools. Why the tool selection change? Is better or worse? What are the factors?
Yeah, great question. So if I capture the question correctly, you meant have we observed, right, empirically, what would be the critical kind of like varying factors there in tool selection? Is that correct? Yes. So that's actually a good question. That's exactly why we cast it under plan, and actually mostly plan and goal. Goal is the final goal that you want the agent to be accomplished, right? The task for, let's say, data retrieval and all that. We realize tool selection, which I'm happy to show the number here. Actually, let me see if I can. I will show that toward the end of the demo. Tool selection actually get affected quite a lot by the reasoning power of the LLM. So basically, tool selection is a highly inconsistent metric if you use a weaker model or non-frontier model to judge. So we do that by doing like a repeated run, and we compute standard deviation, we compute consistency, we also compute rater agreement, meaning what does the judges give you the score versus what is the agent originally generated, and also compare that with the human ground truth. And we found out tool selection and plan quality, the two purple ones, are basically the biggest function of LLM's reasoning capacity. So if we use Cloud for Sonnet or even Cloud for Opus, it gives us the best results in terms of catching the error or error identification. And going like one step deeper, we actually did error localization, meaning can your LLM judges under this decomposition localize the exact span under the reasoning traces, right, the unit of operation? Can they actually localize and pinpoint which step, whether that be in a tool calling step or a reasoning planning step or generation step, which step actually is the source of that error? So that's the reason we devised the different prompt for all 9 judges. So this is both in open source and actually an archive paper. We get a lot of feedbacks on like, is 9 judges really necessary? Like, do you really need 9 metrics to be able to capture all kinds of operational errors of an agent? And our like empirical finding is that the nature of the errors, like the more that is affected or dominated by planning reasoning capability, the higher chance a stronger reasoning model will be able to catch that, which is very intuitive, right? But that's the reason we can't really just have a single LLM judge or a single algorithmic deterministic function to generate your agent's GPA, basically. Like your agent's reliability has to be broken down into many, many dimensions. And we do orthogonality analysis to try to make sure all those dimensions are sort of like pointing to a distinct failure mode so that there are no redundant, evaluation overlaps here. Yeah, does that make sense? Yeah. Thanks for the question. Yes.
Thank you. I was wondering how you handle this recursive bias. Imagine if your agent LLM and the judge LLM, they are using the same architecture.
Yeah.
And
great question. So first of all, the current the reported benchmark numbers that we are pushing out is actually using non-agentic LLM judges, meaning we're using a single model invocations on each of the metric here, right? But I think if I understand it correctly, the deeper question is that what is the ceiling if your predictor, which is your main application agent, right, are being evaluated by the same set of judges or tools, right? If your tool's capacity is almost the Pareto frontier or the ceiling of your main app's performance ceiling, then what are you actually trying to operationalize, or what are you trying to optimize to, right? That's kind of like my understanding to your question. Is that correct? Yeah. So that comes back to the generalization power of a single LLM. I think in the current paradigm, we are toward the cusp of like exploring a frontier, whatever the frontier LLM can do within a single invocation. I think we are close. I think we are in the diminishing return of that phase where the reasoning power of a single LLM is heavily being like just determined by, hey, can you have a more effective attention mechanism, which there's like a new paper recently, right? But with the agentic workflow, things are a lot more complicated. Oftentimes, an agent's performance is dominated by your, let's say, your API robustness, right? Because let's say in all of your toolings, your LLM is only doing the lightest, like not the heaviest lifting work. Maybe it only has to do is to select the right tool of a sea of available tools to it, right? And the rest of it is actually, can your LLM reasonably reason through the tool responses? And that's where the most expensive iteration loops come from. And that determines how your execution traces in production will look like. Oftentimes, your judge LLM, the bottleneck there is like, can it actually understand the long traces with no knowledge of your actual agent architecture, right? What I'm trying to say is that the agent traces can be fairly different from your agent architecture. You can have a super long traces because of a very happenstance, like very unfortunate agent execution that is stuck in one iteration loop because of some tool failures, some API availability issue that you cannot control. That manifests itself as a very wonky execution traces, right? But that fact has nothing to do with your super optimized agentic architecture, right? You could have a very sophisticated multi-agent setup with orchestrator, planner, and all that super state-of-the-art, but still you can have a very, very, I should say, lost of the word, but you can have a very weird execution traces that's actually very trivial for your judge to solve. Does that answer the question about the competing factor? Yeah, thank you. Thank you. Okay, so let me keep going. So yeah, so there are some numbers. I know sounds like we're just bragging, like it's like catching them all. But what really happened here is that we realize we try many different combination of the decomposition, meaning we try many different type of metrics dimension to look at and experiment on which type of breakdown of your performance metrics will be able to capture all the annotated label errors in the current Trail Gaia benchmark. So this is the number that we have. Trail Gaia is an open source benchmark. We also benchmark in an internal data agent within Snowflake, and we reach around 79 to 80 iterators agreement, which in practice usually means we are reaching a sort of like a similar performance if you task this to a set of human beings, if you task this to a set of expert human annotators. 80% is usually kind of like the rule of thumb, like where human agreement or inter-agreement caps out. So yeah. Cool. So let me show a quick demo. Let's see. Is it visible? Yes. So here we have an agent. Let's say the original question is fairly trivial. You have some DB about the analytics or like sales records of your different type of donut. Imagine if you're a donut shop owner, and you ask your agent or your data agent to help you, like kind of like give you an analysis on what's the most popular donut in the morning, right? So in this traces, this is what I meant by the ensemble of this, everything here, like all the text that is being formatted here, if you combine from the first step, the LLM planning step, the analyst, which is our internal tool that perform natural language, the SQL execution and generation, and LLM planning, and all this step combined is what I meant by the execution traces previously. And then finally, your data agent is still responsible for just generate a short pithy sentence to tell, to get back to the user saying, hey, right now people are really going for strawberry frosted donuts. So something's weird here. Logical consistency is not 100%. 67% is what we consider kind of like, if you think about it on a 4-point scale, this only score probably like 2 out of 0, 1, 2, 3, like 3 being a full mark, right? So in this case, the reason that our judges or GPA metrics give it a non-perfect score is because the final answer is telling the user, hey, strawberry frosted is your overall most popular donut. So if we look at the reasoning, you actually see how it captured this. It adapts its approach by looking at the overall popularity instead. This is a crucial step that the agent deviate from the user intent, right? So if we go back to the sort of like a Venn diagram there, it doesn't carry its actions correctly, and it also doesn't follow the initial goal of the user. Because the user is curious about what's the most popular donut in the morning, but there's a subtle logical step or logical skip here. It make a logical mistake saying, it clearly acknowledged that internally it cannot filter by morning hours due to timestamp format limitation, which is actually incorrect. The incorrectness here can, obviously stem from different reasons. It could be what I meant by like API availability, or maybe your RBAC, right? Your rollback access control on your DB just doesn't allow you to filter by timestamp, or it could be a DB version issue, whatever. However, the important thing is that the actual error the agent made is a logical step or a logical skip. If it assumed giving you back the most popular donut of all time, it's going to be satisfactory, right? That's what we meant by a non-perfect logical consistency answer. So another trace, which is the exact same question, we ask the same agent what donut is most popular in the morning, and in this case, the final answer gives, I think, based on the morning orders, So you can kind of like guess like it actually has the proper understanding or concept of a time, right? Understanding of recency or now here. So this is what I meant by a perfect logical consistency for this very trivial examples. In practice, we have something way more involving. So I'm just going to quickly flash an agent with many, many steps. I think this is performing a charting task. Yes, the question is chart the current market capitalization of the top 5 banks in the United States. So the reason like we dinged it for execution efficiency is because of there are redundant function calls here. The detail doesn't matter, but what matters is this is the reason why it doesn't get a full mark on execution efficiency. Yeah. And then finally, the answer is not fully grounded because I think it missed a critical piece of one of the bank's performance over the past year. But yeah, so that's toward the end of my quick demo. Any questions? Am I running out of time? Or okay, cool. Let's open up for some questions. Go ahead.
Do your GPA scores change if you use a different frontier model? Like instead of using Claude Opus 4.1 to generate those scores, you use Claude Opus 4.5?
Mm-hmm. Yes. So that's a great question. So the reason I keep mentioning this is a framework instead of a toolkit is because this is not a managed solution, even though Snowflake does offer that. But as a framework, this is more or less model agnostic. If you switch to a non-frontier model, that's a GPT 3.5 Turbo, I'm pretty sure your scores, overall score of the same agent execution will drop significantly, or it will vary quite a lot. Yes. So it is still a function of the generation quality of your LLM judges. Yes.
Just a quick question on the orchestration agent. If you have like multi-agents working,
yes.
Why isn't the orchestrator kind of doing a little bit more to check that the one that's working or the ones that are working are going through the triad and kind of tell them to go back and do the right thing? Like, isn't that yeah?
Yeah, so just to clarify, are you asking what's the main reasons or paradigms we observe for those cases, like the
No, I'm just curious, like if you have multiple agents working together to do some task, like in Snowflake, you're doing some normalization or something, and like each agent, one is acting as a data scientist and data engineer, ETL, and then one is just the orchestrator. You know, let's say, if they report back to that one orchestrator agent, why isn't it saying, you know what, you kind of failed here in your GPA, right?
Right.
And like, is that how much attention is going into the orchestrator?
Right. Yeah, great question. So that's something that wasn't in the slides, but that's what I meant by localization or error localization. So if we go back to some of the metrics, I'm not going to bore you with the details of the metrics, but let's just say if your execution efficiency is not perfect in this diagram, if your execution efficiency is not perfect, oftentimes it is able to actually localize to the actual span ID. So when we are doing this experiment, not sure how many folks are familiar with OpenTelemetry. So we actually evaluated on this open source, fairly commonly used format from logging. So all the traces are logged in an OTel format, OpenTelemetry format. So it has all the parent-children spans ID to basically allow the agent to reason through from a small window of the actual agent architecture. So if you have a multiple agent set up, given the full trace, the execution efficiency judge is able to reason through which, which sub-agent or which agent is the orchestrator versus which agent is the executor, if that makes sense. So your planner or orchestrator can be doing perfect job with perfect logical consistency, perfect soundness or groundness. However, you can still have lower execution efficiency score because of some redundant loops that is going there. So that's why we actually trying to advocate for very fine-grained decomposed evaluation instead of a single evaluation to try to catch them all. Yeah, does it make sense? Cool. Yes.
Yeah. So is it possible for the agent to deviate because of some guardrails? And do you guys consider that in your evaluations as well?
Great question. Yeah. So a lot of details, super relevant. Plan adherence is something, the reason we devise plan adherence or we design plan adherence is because you could have user intent that is actually being blocked by some guardrails, so that doesn't get carried out or doesn't get fulfilled, right? So it's important to kind of assess both, let's say, your answer correctness. In the case of guardrail, maybe you didn't get to the correct answer because the correct answer is actually kind of adversarial or dangerous, right? So you would probably get a very low answer correctness score because that metric does require the ground truth. But you can still get perfect plan adherence score in those cases because of the exposed execution traces. So as long as your guardrails are being manifested as some sort of execution traces, then plan adherence should theoretically be able to capture that, saying, hey, you are adhering to your plan because apparently you have some guardrail turned on. However, you fail with your answer relevance or answer correctness. And we can go even one step deeper, saying you fail your answer correctness, but your answer is still relevant because you say something like, oh, sorry, I cannot answer this question because it violates XYZ community guidelines. Right? Does that make sense? Yeah.
Thank you. So context plays a huge part in giving us a result from the LLM as well as while judging with these metrics. So are these metrics going to judge based on a global context or on a specific context?
Yeah, another great question. So for now, because of everything is being hinged upon the execution traces, so I personally would argue this is a local view of what actually was happening, right? So, and then when you define a global context, it's also kind of interesting and important to make a distinction between the latent world knowledge of the model that it memorized, right? Let's say the model oftentimes 2 years ago will say, hey, 9.11 is smaller than 9.9 because of, well, if you look at the model internals, you realize, oh, this is because the model is trained on the Bible heavily. So, there's these sort of things that play the role as a context versus the working memory, the more recent memory you try to inject during the agent execution loop, right? Let's say there are some recent work to do adaptive context engineering, meaning you basically accumulate and you revise, you update, edit, refine the context as the agents progress in its different steps, right? In those cases, I will argue this is still a very global view. Still a very local view. However, logical consistency should be able to act upon that to say your current step is your current step always grounded by its previous step, right? So, and then going beyond that, that will like probably require some architectural changes. Like current LLM, we probably talked about limits of the current LLM. But does that answer your question? Yeah, partially. Okay, I will try to do that there. Next one. Yeah. Yes.
And how is that local context provided? It's again through the answers that you receive from the LLM. So the basis for the context and the judgment are the same. So how would it be that?
I see. So in this view, right, there isn't I should say explicit metric to judge the context per se. The reason being, you're absolutely right. The context, a lot of time, there could be the description, metadata of your tool, and all that kind of information that is being fed to the agent. What if those information are not being manifested as the execution traces, right? What if the agent just assume it knows that and then give a very short like sentence saying, oh, I'm now going to look at my internal enterprise doc and then come back with the answer. So in your execution traces surface, in the surface area that you can attack, you only see that sentence. Your judge has no knowledge of what's a hidden context whatsoever. With that being said, though, the reason number 2 or logical consistency is in the middle is because we argue logical consistency act on the abstract layer. So you could have context that's being corrupted or context that's being like injected without you knowing that, but you can still get a really good logical consistency step. That doesn't mean your agent is evolving its context correctly or adapting to its context correctly, right? You have to look at the other metrics. So even though they are orthogonal to each other, but they do play hand in hand. So yeah, is that fair in there? Cool. Yeah.
I have a question about, have you used this in practice? Like, are there clients now using this?
Yes.
Is this like?
Yeah, so this is part of our agentic evals private preview offering. This is also blog post is kind of like a condensed version or a better written version of what I mentioned today. But we do have, if you guys are interested, there's a full archive paper. There is a full archive paper talking through how we actually devise the agents themselves. And finally, we do share all the prompts and we do share all the formats of the data toward the end. So I think in the appendix, we have the, feel free to take a look at the experimentation sections. And we also have all the prompt that we share. Yeah.
Just one last question. Is it in practice, is it being applied for all agent responses and traces, or just the sampling periodically to monitor? Because it can be costly if it is for everything.
Yeah, great question. So the framework itself is agnostic to that, but in a pragmatic sense, currently we do this by an offline batch evaluation manner. So you could decide if you want to have different type of sampling rate. This is, you can derive it from the UI, you can derive it from the COI or SDK. One of the challenges in practice is trace compression or the length of the trace. Because oftentimes, for you to be able to extract very, very reasonable and very useful scores, you have to have that exposed to all the LLMs and do expensive computation. And that's why I mentioned the average traces, average length of the traces we observe in our production clients, it's around like 100 to 150,000 tokens. So this is definitely a challenge, and it's also an active research area of a company to perform adaptive trace compression. What are the actual useful information, right, in the entire traces that we should feed into the metric judges? Yeah.
Cool. Thank you very much, everyone. Thanks again to Daniel. Let's hear it for him. Okay, don't leave. I gotta run a raffle. Let's see who won the $25 Amazon gift card.
Okay. So yeah, our team is hiring. So by the way, our AI research team is hiring. The observability team is also hiring. So they're just flashing the QR code here. Yeah. thank you all. Oh, just leave it here for a few seconds. Yeah.
By the way, thank you so much for giving all the feedback. I've already shared the feedback with my team, and I really appreciate you taking the time. And I have collected all the names from the form entries, and I'm going to run a raffle. If you are the winner, please come after the event. Come to me so I can take your email addresses, and we can send you the gift card. Sir, all right, there we go. Okay, one more time. All right. Thank you, everyone, for this lovely evening. Thank you to all the speakers. And we have the room here till 8 or 8:15. Feel free to...
8 o'clock.
Oh, 8 o'clock. My bad. So you have exactly 10 minutes to network more. Hope to see you in the next event. Have a good night.
Thank you so much.